Hi, everybody. Welcome to another SharkNet General Interest webinar. My name is Armin Sobani, and I'm a SharkNet HPC technical consultant based at Ontario Tech University. And here is my email for any further consultations after this talk is over. In today's talk, we will continue our subject about remote development on HPC clusters with VS Code. In the previous talk, that here you can find the link to the recorded video on SharkNet's YouTube channel. We covered configuring SSH agent and config file, version controlling with external repositories, adding makefile and CMake support, and finally remote debugging on compute nodes using the proxy jump method. This is also the link to the materials on GitHub. What follows today is first remote debugging using the SSH tunneling method, and last but not least, the remote debugging of CUDA codes using Nsight Visual Studio Code Edition. As mentioned previously, remote development on HPC clusters can be done both on login and compute nodes. While working on logging nodes has minimal setup and is kind of convenient, it's not a good candidate for debugging, because debugging may put stress on the login nodes. And if you're debugging CUDA codes or your code that requires a large amount of memory, it's not even possible on login nodes. There's also some problems with this approach. For example, all the packages or modules that you want to use during your development or debugging must be already put in your .bashrc in your home directory. Remote development on compute nodes, on the other hand, can be done in two ways. In previous session, we already covered SSH proxy jump, also known as jump hosts method. The problems with this method is that you require to add your public key to authorized keys on each cluster, because compute nodes don't respect your uploaded SSH keys to the CCDB. And it has also the same problem as login nodes. You should add all the required packages or modules in your .bashrc file. The SSH tunneling, also known as port forwarding, is the method that we are going to cover first today. The problem with this approach is that some VS Code extensions are not working or not even available using this method. For example, the Nsight that we are going to use today is not available. And because of that, for the second part of today's talk, I'm going again to use the SSH proxy jump method to do that. And another problem is that your development environment must be set up on each cluster individually. So unlike the SSH proxy jump, that you have your same VS Code environment and you don't have to change anything, and because you can connect to each of the clusters and working, using this method, you have to do all the settings again for each cluster. So as you can see, there is no perfect solution. So let's switch to live session to see how SSH tunneling works, but a word of warning is in order. Because we are going to work on our clusters while they are providing service to other users, it's completely possible some glitches happen at any time. Hopefully there will be none for today. So let's see. I try now to, let me first go to the web browser. If you go to the Alliance documentation wiki page and search for SSH tunneling, the method that we are going to use today, you ended up in this page that explains the whole idea and how it works. So let me first, in my terminal, connect to Graham, for example, one of the clusters. You can use any one of them. Because we've already, configured our config.ssh, SSH config file in the .ssh folder, and we put Graham. You can see it in the, previous, session, the video. I need to only use SSH Graham rather than my username and complete the FQDN of the Graham, for example, and that's really convenient. There is a software called Code Server that fortunately we have on our clusters as a module. So on the Alliance clusters, there are two ways of using port forwarding in order to run VS Code on compute nodes. Easy way and the hard. I'm going to demonstrate or show you the hard way first because it shows all the things that happens under the hood for the easy way. So there is a software called the Code Server. If I do module show Code Server here, it allows you to run VS Code on any machine, anywhere, and access it in the browser. The only thing that you need to do is first module load Code Server on our clusters. And once you did that, you have to run it like this. When you run it first time, if it is the first time that you run it on one of the clusters, it writes a config file under this path that has some configuration. We don't want to run it. Usually we don't want to run it on the login node. We use this approach to run it on the compute node. So I press Control C here. I just did it to have this file generated. And I can show you the content of this file. We need it because in this config file, when it generates a random password like this that you needed to access it later when we are going to connect to our local host. So after doing this, now if we want to run it on our compute node rather than the login node, we have to use first salloc command. And we can also use module load to load any modules that we need. So for example, if we need CMake, which we have for this project that we have in the GitHub, I can do module CMake, or even if we want to do the CUDA, I first load these modules. And after that, I use salloc command to allocate an interactive session or a compute node. So I start with my account, which I use CC Debug here. You should put your account information here. And the time for this, I use 30 minutes for this one. And it's good to have a memory. Usually 2 GB is enough, but because the standard one is 4 GB for each core, and we are going to use one core, I go with the 4 GB of memory here. After ending, we are ended up in our, compute node, which is graph 49 here. We need to run the Code Server again. But now we should provide the address for, maybe not bad to show you this. I don't know which is, it is help or there are some options that you use for the Code Server. The one that we are going to use is bind address, this one. So here I use bind address, and because we are on graph 49, we use graph 49 and a port number. Usually this port number can be anything, but one thing that is close to default web port, for HTTP is 8080. So 8080 is a good starting choice. We want to run it on this port on the compute node. So I run it like this. After running that, it shows that it's now listening on this IP address and this port number. So our server is started on our compute node. But the problem is that compute nodes don't have access to internet. So we can't connect them directly from our computer to this. What we can do now, the SSH tunneling or port forwarding method comes to the rescue. So if I open another terminal window here, I have to now start an SSH tunnel to this compute node. How can I do that? I use the SSH command on my computer, and there is an option for local port forwarding, because port forwarding actually can be done in two ways: local port forwarding and remote port forwarding. We are using the local port forwarding, which the option for that is capital L. And then we should specify the local port on our computer that we are going to connect, which we choose the same one as the remote one, which is 8080. And then we can copy this part and paste it here. There is another option that we should specify, which is capital N, to not start a session or terminal on the remote one. And there is also another one, dash F, but you can't omit that one as well. After that, we should specify the cluster that we want to connect. Because we have the information in our config file, we just use Graham. But if you don't have it, you should specify the complete username at grahamcomputecanada.ca. But this would suffice. So here you can see that sometimes that happens because previously I used this port so on my computer. So I can actually stop this. There is no need to the both port be the same, but for convenience and preventing confusion, we usually use the same port. But when something like this happens, you can switch to another port. So let me use this one on my local machine. Again, because I use this as well. It's always like that. So let me switch to another one, maybe 9,000. Okay. This one, this is on my local computer because I, for checking, I use that and I didn't close this window. It's not working, but usually when you start it first, it should work. Now we have our SSH tunnel to the compute node, but on our local machine, we should use this port number to connect that. For doing that, you just switch to your web browser and go to localhost and change the port to the local one, which for this one, I use, as you can see, 9,000, like this. This one is the password that I showed you, which was generated by code server. So I have to scroll up here and go to this one and copy this and paste it here. After doing this, the code server is running. I can, for example, choose the dark mode here. and continue to the next and next and done. Now I am on compute node on Graham using the code server version of the VS Code. So it works more or less the same. Another problem with this approach is that the version of the code server might be not as updated as your local, VS Code on your computer, and some of the features missing, for example. But once you are here, you can, for example, start cloning or, go to a folder like this, clone a repository or open folder. So because I already have it on Graham on my development folder on project, I go there and I choose the same repository that we have for this and press OK here. So these files are on Graham and we are on compute node. How we can tell? Because if I turn on the terminal, you can see that we are on Gra 49. And all the modules that we actually load, for example, CMake and other things are already there. So you can see it here. I can make it even a little bit bigger. So that's the way it works. So the other things like this, but what I'm going to show you later is that the only difference is the extension here. So this one is, it works like ordinary VS Code, maybe a little bit, slower, and some of the features may be missing. But the good thing is that you don't have to load the modules in the .bash RC. And another good thing is that there is an easier way to achieve the whole thing. So let me switch to that one as well to show you. It shows that we are on localhost 9000 here. So after I finished, working with this, I can close this, for example, and switch to my terminal window and exit from this one because we don't actually use it, and press Control-C to stop the server. And if I don't need my compute node, I can also exit to terminate my allocation. So that's all there is to it. This is the hard way of using this method. But there on the Alliance clusters, there is an easier way to do that using the Jupyter Lab. So let's see how we can do that in that way. If you go to documentation wiki and search for Jupyter Hub or Jupyter Lab, both ends up to the same page, you can see that on most of our clusters, now we have a Jupyter Hub service. Depending on what cluster you want to work, you can select one of them. But let me tell you this, the only one that works now is Cedar, because there was a problem. There was an update to the VS Code server, actually code server thing, that it was updated in our CVMFS, but it's not still taking effect. And because of that, on other clusters doesn't work. I'll show you why it doesn't work. But the only one that is now working is Cedar. So I'm going to this one. I just right click on this and open link in a new tab. The whole information is here. And if you want to run code in VS Code, if you scroll down to this or click on this link, it shows how you should run it. But I'm going to show you how. After logging using your credentials, the same credentials as CCDB, You have some options. For example, if you have a reservation, you can choose and I don't have any reservation here, and you can switch to type of the account. So for example, if you want to run GPU code, you can switch to GPU, but for this one, I use only CPU. So here, for the time, I just select half an hour. Some of them, there are some restrictions. For example, for this one, for consider, you can't go less than half an hour. But for example, on Graham, you can choose even a quarter or 15 minutes. But for this is the minimum one, and you can choose the number of cores and the memory. Once you put this, they become default. So it means that next time you go this, you see the same numbers that you entered previously. So if yours is different, it's because that I've changed it in the past. And if you want to have a GPU code, you can, have, depending on the cluster and available nodes, you can choose which one you want. But for this one, I don't want to have any GPUs. And the user interface is better to go with Jupyter Lab rather than Jupyter Notebook. So these are the choices that I already made. And then stop. Depending on the time and, fair share and those things, it may take a little bit. While it's finishing, let me also begin to buy some time. Let me show you what happens on other clusters. So for example, on Graham, what's wrong that it doesn't work? So I try another one. Isn't this more or less the same on Graham? Okay, the one on Cedar already finished. After it's finished, there are some, icons or buttons here. It ends up on the loaded modules. There are some default modules that are already loaded. For working with VS Code, the one that you need to load is code server, like the one that we did. So as soon as you scroll down and select the code server here, I go with the latest version available, which is 3.12. As soon as I load this, you see that the VS Code icon appears here. If you need any other module to work, for example, if you need for CMake, you can also load that. And after you finish with the modules, you launch the VS Code. It opens in another window. So here it is. Because it's on, Cedar, you can open a folder, go to, for example, development. Because I don't have the repository here, like the one that we showed, we can, rather than going with this one, we can clone repository, going to our VS Code one, copy this, and paste it here. And it asks, where should I put it? In development? Okay. Okay, after it's finished, we can open it in the same window. So all the files that we have are now here. We can start editing them, open, and work on them. So here is the problem with this approach, as I told you. The whole problem is related to VS Code server. But let me, before going to this, I show you what happens on other clusters. Because of the problem that I told you, let me make it bigger. On other clusters, if you scroll down to code server here, and load, VS Code icons doesn't have, appear here. That's the problem. It's already fixed, but it may take some time. You can, check it in coming days and it may start working because the problem is already fixed. But for today, unfortunately, the only, cluster that works is the Cedar. But that's a problem that I told you that prevents you doing the same thing on other clusters currently. So after you finish with that, you can, for example, log out. I don't need the Graham one anymore, but let's switch to the, our Jupyter, VS Code instance on Cedar. Here, the only, the most important problem, at least for me with this approach, is that the extensions that are here are different from the default VS Code store. Why? You can find the reason in code server fact or frequently asked question that I, have it here. This code server developed by another party, not Microsoft, and because of that, they don't have access to because the whole VS Code is open source, but the marketplace published by Microsoft extensions are not. And because of that, those extensions are not available in code server. Some of them are, for example, the one that I mostly use, let me show you here, is C++ thing that I have some problems using that, as you can see. And if I try other ones, for example, CMake, which is developed by Microsoft as well, CMake tools, when I install it, it has problem and it doesn't work. Again, you can see that it's happened here. And some of the extensions, for example, Nsight, which we are going to use today by NVIDIA for debugging GPU code, is not even available on the store. So that's the main problem with this approach. Maybe later they, have a solution for that. But if you want to only edit your files on our servers using the VS Code, and you want to run it on, for example, compute node, the most convenient way is now this way, using the Jupyter Lab or Jupyter Hub. So that's the caveat that I just wanted to show you. Another thing that you should also consider, as I told you, is that for each instance of code server that you run on different cluster, you should do all the settings that you have. So for example, I have lots of settings on my local Visual Studio code that all preserved while I'm doing the remote development. So I don't have to change anything. But using this approach, you should do it, repeat the whole procedure, whole setup on each clusters. So that's another problem with this approach. So after having, showed you this, one that is remained from the previous, session, it's now time to switch to doing remote debugging using Nsight Visual Studio Edition by NVIDIA. So I close this one and also log out from this Jupyter Lab instance. Okay. Now let's see how we can do the remote debugging of GPU code. For this one, as I already said, because this method doesn't work, we have to switch to proxy jumping method that we used in the previous session. But it's a good thing because I do it again to the, like a, rewind for you to show you how all the steps necessary to do a remote debugging using the proxy jumping method. So as we said here, you need your config file ready because in this method, we have to change it. For this debugging, I choose to go with Narwhal because there are more GPUs on that and all of them are more the same, A100. So let's start with that, but maybe later I show you how it works on Graham as well, if we have time. So here, the first thing that we need to do is I've already have the repository on Narwhal. So what should I do is to open, let me open another tab. And because I have the information for Narwhal on my config file, I just can do SSH Narwhal. But two things that I need to, check with you first here. For this debugging session on GPU, the things that we need in addition to Visual Studio Code, we need the C++ extension, which is already part of the C++ extension pack. And another extension that we need is Nsight Visual Studio Code Edition. If you don't have them, you can, install it using this link or directly from the extension of your VS Code. And another thing is that we have to module load the necessary things in, put this one in our .bash RC. So for this one, we don't actually need SciPy stack and IPy kernel because they are for, Jupyter page that we already, demonstrated in the previous session. So just module load CMake and CUDA will be enough to be in your .bash RC. So first thing that I need to do is to check whether my that bash RC file has it. So you can see that for personally, I put some of the module load commands for different projects, and I comment out some of them depending on what I want to do. So here is the whole thing. Because for this one, for example, I don't want this two other one. I can even delete them and then save it. I have to relog in to make it effective. And after that, now I can allocate my GPU node or GPU compute node. I have some of the commands. Let me check, for example, some of my salloc. Let's check which one is good. So for this one, I go with 30 minutes and 4 GB of memory. And please also notice the new syntax for requesting GPU. So in the past, it was like this, but now you can use like this one. So if I want to use this command, I can use this. This almost perfect for me. We ask for 30 minutes and 4 GB of memory and 1 GPU node, whichever it is, because they are more or less all the same. Having allocated our node, compute node, which is this one, we can copy. And then in our config file, we can update the VSCode Narwhal entry with the compute node name. And another thing that I should mention is that because as I already said this, because compute nodes don't respect your uploaded SSH key in CCDB, you have to copy it to the .ssh of your the cluster as well. So I've already done that. If you haven't done it, you can check, the previous video for the previous session, and using, for example, SSH copy ID command or the command that I used in the video to upload your key to the server. So it's already there. Because it's there, now I can update this and save the config file. And now I can go to command palette and choose remote SSH. But remote SSH has, extension, adds a icon here, which is Remote Explorer. This one is more convenient way to do that. So after updating the config file with the name of the compute node and saving it, you can switch to Remote Explorer here. And the good thing is that all of your previous sessions with the projects are there. So you can see that VS Code Narwhal is already there. And if I want to open the VS Code HPC that I've already put it there, the only thing that I need to do is open on SSH host in new window. By clicking on this, it opens a new instance and tries to connect. So I have to answer continue with this. Once it finishes, it automatically tries to configure the whole project because we have a CMake file. This you can ignore these errors. It's not really important, but the whole thing is configured and the CMake generated. If I switch to terminal, you can see that we are now actually on our compute node that has a GPU. And you can also check it with NVIDIA SMI to see that is actually on one of the A100 nodes. Now that we have it, we can start to debug our CUDA code. We had an MCPI CUDA code in the whole project, in the repository, that we can try to debug. In order to do that, we have to go to the here, this debug icon here. If you remember, for debugging the CPU codes, for example, MPI version and those things, we use the CMake tool icons here to debug. For example, this one for debugging. But because this one only launches the GDB debugger, not the NVIDIA GDB debugger, we have to configure the CUDA or NVIDIA GDB debugger using this method. You can't use this because this one can only debug the CPU. For doing that, you first go to run and debug here. And for the first time, you have to click on this one and make a launch JSON file here. If you don't have it, you can select add configuration because it's not the first time that I'm doing this. The file is already there. When you do that, all of the things are already there. The only thing that you need to update is this one, which is the path to the program. For this, you have to specify it like this. You start with the variable workspace folder, which starts at the workspace folder, and then you should go to the build, CUDA, and MCPI CUDA. You have to type this one there because it's the only one that uses the CUDA GDB. We have to configure it for this one. The other programs you can, for debugging them, you can use this button here and select them from here. After saving this file, now you can go to your GPU code and put your breakpoints. I put one of them in the kernel one or the device code, and another one in the host code. This one is the host. And after having our breakpoints, we can now launch the debugger by clicking on this. And these are the buttons for the debug. You see that we ended up and running on the host code, and we can use F10 button to go one by one, or these buttons a step over from here to go a step by step. Something is going on. Let me see. It doesn't show the variables. So let me stop first here. It seems that something is wrong with it. Happens sometimes with Narwhal. I usually don't have this problem with Graham. It seems that our compute node is working, but the whole thing is not responsive. Oh, okay, finally. So let me remove. Okay, so let me see what is going on here. Maybe first thing, another thing that you should check is that for debugging, you have to switch to debug version. So let me do this again, switch to the debug, and then build the whole project again. Okay. Now let me go and remove all these breakpoints. Maybe from the previous sessions, it makes it. Okay. Now let me put the breakpoints again, one in the device code, start of the device code, and one at the start of the host code, and run the whole thing. Okay, seems it's working now. Okay, we are now in the host code. You can see all the local registers and all the local variables. These are the variables and the things. You can go step by step like this. And these are CPU registers, as you can see. And you can see also the call stack, one for CUDA and one for main program. Let me make a little bit bigger. Okay. Now we can go step by step like this. So here, after having the thing, if you go to debug console with CUDA, you can see the output of this command, which is, it shows that we are on CUDA GPU using 128 thread, and the device name is NVIDIA A100 with 40 gigabyte of memory, and this is the number of tasks. So we can go, and here is the line that tries to launch our kernel. As soon as we go there, it goes automatically to our breakpoint in the kernel or device code. When you switch to the device code, you can see all the GPU registers here. And also you can put optimize, you can check the variables, but these are optimized out. The reason is that you have to put a conditional. There are lots of threads. You have to put a conditional breakpoint like this. For example, here, let me do that. I don't here. If you put add conditional breakpoint, you can put a breakpoint for a special, values for rank and size. But another way to do that is the changing your focus. Because we are using the Nsight, you can change the focus of the code here by clicking on this and change that. I don't know, sometimes it doesn't work. When you click on this, it should show you the, give you the option to change your focus. But let me show you another thing. Let's see if it works. Here you can put all the GDB, NVIDIA GDB, the debugging commands here. But the caveat is that you should start all of the commands with backtick. So if you put this and put help, oh, it doesn't work. Thread, hit breakpoint. Something is going on. This happens sometimes on, as I told you, on Narwhal. Usually on Graham, I don't have this problem. I can try to do it on thing. But one more thing that you should check if you have problems, it's not a bad time to tell you this. Let me stop this session here. One thing, if you encounter problems during your debug, one thing that you should check is that by going to your CMake, oh, it seems that, yeah, it seems that the compute node is, that's the problem. Yeah, disconnected. Okay, so this thing happens sometimes on Narwhal. Usually on Graham, I don't have this problem. So I'll show you, but let me show you this one that I wanted to show you. On CMake extension, if you go here, one thing that you should usually check is that if you go to edit CMake catch, usually the CMake script is configured in a way that it's automatically try to detect the correct CUDA architecture. So here, because if I show you, if you check the GPU with the Slurm page on documentation wiki, there is a table here that shows that on different clusters, what type of GPUs are there and what is the compute capability of that. This is the number like that. So if you check on Narwhal is 80, sometimes this one is not detected properly, especially on clusters that have a heterogeneous set of GPUs. So you should, change it to the minimum version for that. For example, on Graham, the minimum version, depending on the GPU of the compute capability is 60. So you may change this to 60 or even lower on Graham, for example, to compile your code with that. But let me, because we have a little bit of time here, let me quickly try to see if I can show you on Graham the same thing or not. The only thing that I need here is to just do the same thing on Graham. So let me exit from this and use the same allocation here on Graham. Okay, now I should copy this and here update my VS Code Graham to the node and save the file. And after doing that, here I can go to VS Code Graham and this VS Code HPC. Okay. Oh, here on Graham, I have to provide one-time password. It's only for staff, not for you. Okay. I've already configured that, and let me show you this, that on Graham, the CMake script automatically, if you check that, the compute capability switch to 52. So it works actually. But if it doesn't, you can change it to one that depending on the exact node that you selected, the exact GPU that you selected. But it should work now. And we have our, let me remove all previous ones and set new ones. I put one near the call to the kernel and one at the top of the kernel. And now we can launch the CUDA debugger. Okay, so it shows that we are at this phase. If I put F10, I go here, and this is the one that you can change the focus here to the block and thread number and check the values. But you can also use this tick command. For example, you can use if you put help, it shows all the available, things that you can use. And you can use, for example, info CUDA. If you put help, for example, here, it shows all the things that you can put. So here you can put info CUDA, for example, and see devices. So we are actually on this Tesla device, which has a compute capability of 60. And these are the number of streaming and lanes and other things. And you can also check for the CUDA kernels. Oh, maybe not kernels here. Oh, it is another. I shouldn't use the info CUDA for this, but it should do. Okay. So this is our kernel and shows that the block dimension and grid dimension here. And you can also ask for lanes and blocks and threads as well, like this one. But the thing that you should notice is that you should, preset your commands with backtick here in order to work. And then you can go one by one, step by step to the code and check the whole thing. I think we are at the end of the hour, so that will conclude our session for today. If there is a question, I'll be more than happy to address that.